just more practice with logs. So there's really nothing new on this day. It's just, practice with expanding and compressing and equations and the whole bit. So to solve equations, that's really our fundamental reason for doing logs. You're going to rewrite, again, with one term on each side. You're going to write it as a log, and you're going to solve the equation. Right? That's what we just did. So hopefully there's more practice. When solving logarithmic equations, you want to either end up with a log. Okay, so now we're going to do logarithmic equations. You want to end up with a log on one side of the equation, and if this is the case, you write it as an exponential form. So for example, what they're saying is, now I'm going to work with logs. So if I have the ln of x equals 2, to get rid of this, when I have one log in a number, I'm going to write it as an exponent. All right, so what's the opposite of ln? E. So I would say e squared equals x, and that's my solution. All right. So when you work with logs, you want to write them as exponents. When you work with exponents, you write them as logs. Okay? Yeah, so it's all about working backwards. All right, 2 logs of the same base on each side, you may cancel them and solve. So this is the deal. If I have the ln of x equals the ln of 2, you see that you have one log on each side? The only way these can be equal is that x has to equal 2. Okay? So if you have one log on each side, they can cancel each other out. All right? Only one log. You can only have one log, not many logs. Just one log. Okay? That's where some of our log rules come into play. Okay, you should never have an equation with more than 2 logs, meaning one log on each side. Okay, otherwise you're not going to get the right answer. So we have to condense like we did yesterday. All right, so some practice here. I want to get rid of log base 3. It's on its own, so I'm going to write it as an exponential. So what's the base? So I say 3 to the 4 equals, and then I go ahead and solve. Okay, so 3 to the 4th is, that equals. So if I subtract 2, I get 79. Now with logs, you do one little check, just one check. Make sure that when you plug this answer back into the thingy here, what is that called? The argument of the log, you don't get a negative number. Why do when I want a negative number and then argument? Can't take the log of a negative, right? Sometimes you'll get extraneous answers when you work with logs, so you have to check that. All right, but that's fine because 79 plus 2 is 81. All right, so what about the next one? I'm going to have to isolate the log first. So what would I do first? Subtract 4. So I have the ln of x. 2 minus 4 is negative 2. So now I'm going to get rid of the ln. So I'm going to write it as e. So e to the negative 2 equals x. All right, and that's fine. Okay? And you would plug that in the calculator. Good with that? Did we just do that one? No, it just seems awful familiar. All right. So you got a logarithmic equation. You're going to write it as e, right? So how would I write it? Equals x plus 4. E squared is just a number. So x would be e squared minus 4, right? And I just plug that in my calculator. Which I don't have my calculator here. It's not e to the 2 minus 4, right? It's e squared minus 4. E squared minus 4. I get 3.389. Okay. Now, we're going to, can I skip number 4? We just did that one, or something like it. Would you know what to do? It's an exponential, so that means I'm going to take a log, right? But what do I have to do first? Well, maybe I should do it. What do I do first? Huh? Divide by 125. So what's 250 divided by 125? 2. Okay, so I got to get rid of the e. So how do I get rid of an e? ln. So the ln of what? 2. Right, switch y and x equals 2.5x. Is that right? The ln of 2 is just a number. Let's plug in my calculator. 0.693. And you would divide by 2.5 and get your answer right. 0.277. right, this next one, what's my problem? What did I tell you about log? Yeah, I got two logs, right? So this is where I'm going to need to use some log rules to fix life, okay? So I want to combine the two logs into one log. The problem is I've got this 2 in the way. So if I use my log rules, what can I do with that 2? Put it upstairs and make an exponent. All right, so this becomes log base 3 of x plus 4 squared, right? Minus log base 3 of 9 equals 5. All right, and so now I'm ready to use subtraction turns into division. So it's log base 3 of x plus 4 squared over 9. Is that right? Yes? Equals 5. All right, so now I have one log. Okay, I have to get down to one log. All right, we happy with that? So now I can write it as an exponent. All right, so I get what? 3 to the? How do I do? Switch one x, right? 3 to the 5. Good. Equals x plus 4 squared over 9. All right, and this isn't as scary as it looks because I'm just going to multiply by 9. So I'm going to do 3 to the 5th on my calculator. I get 243 equals x plus 4 squared over 9. So what would I do next? Multiply by 9. So I get 2,187. Okay, and you don't want to FOIL this out because you're going to square root it, right? So just take the square root of both sides. Then it's probably not going to be a nice number. Yeah, I get 46.765. Now the one thing that's important here is plus or minus. All right, don't forget the plus or minus when you take a square root. All right, and then I'm going to subtract 4. So I get 46.765 minus 4. I get 42.765. And yeah, I got to do the other one. So negative 46.765 minus 4. I get negative 50.765. Was this a log equation to begin with? Yes. Okay. The negative is not going to be any good. Why? Let's go back up here. Right? Because what we started with was this. And so when you plug in the negative number, you can't take the log of the negative number, right? So the negative solution is extraneous. Okay? So I don't know that until I'm done. All right, so this is not a solution, because you can't take the log of the number, the negative. All right? So that happens frequently, plus and minus, so it's a nice. It's good. All right. We good? All right. Okay, what would you do on this equation number 6? You tell me. Multiply by 2, right? So I get 3 to the x plus 2 equals 18. And then I ask myself, are those powers of the same number? Are they? No, right? 18 is not power 3. So what I'm going to do is take the log, all right? So I'm going to do log base, what's my base? 3 of 18 equals x plus 2. And then log base 3 of 18, I'm just going to type it in my calculator so I get the number down. Alpha window 5, log base 3 of 18. So I get 2.631. So my last step is just subtract 2 over that. So I get x equals 2.631. Is that all right?
Would you get a different answer if you subtracted 2 first? Like 2 from 18?
You can't make it log base 3 of 16. Right? No, because what you're doing is this is not in the log, right? It's just a number. You could write it as log base 3 of 18. And this is really important because people do this, minus 2, right? But you can't make it log base 3 of 16. Okay, you'll get the wrong answer. Because you're not taking the log of 2, right? So it doesn't go in the log. All right, number 7, you have options. Sometimes you have options, okay? I have to get rid of 5, and you're right, whoever said divide by 5, you're absolutely right. That's what I would choose to do, all right? The 5 could come up top, and I could make it 3x to the 5th, right? But why would I choose not to do that? It's harder, right? It's harder. So why not just divide by 5 at the beginning? So if I divide by 5, I get log base 3 of 3x. What's 15 divided by 5? That's 3. Well, I can pretty much tell you. All right, we're going to solve it anyways. All right, so we're going to write it as, now we're going to write it as exponent. Yes, can you get rid of the log? So the base is?
Isn't it x plus x equals 3?
3 times, yeah, it is. Or no, is it 9? It's 9. 9. Okay, I can tell by looking at it. We're gonna solve it anyways. All right. So 3 to the 3rd equals 3x. What's 3 to the 3rd? 27. Not 9. Yeah. Equals 3x. Divide by 3 and you get 9. And that makes sense because if 3 times 9 is 27 up here with this log, the log base 3 of 27, yeah, that's 3, right? That works. Okay? Yes, check it. Some of you can check.
So why don't they cancel like?
Huh?
Like they four, you know how you said that they cancel, they have like some base?
They cancel when you have exponents, right? Like if you have 3 to the x equals 3 to the 2x, then they cancel, right? But we're not dealing with exponents here, so they don't cancel, all right? If you have one log on each side, then the logs will cancel. We haven't seen that yet, so we'll look at that, okay? I don't want to do that one right now. Yes, I do. This is not in your notes, right? Do you have one with logs on each side? No, I want to do one of those for you.
We don't have any more.
Yeah, I'm gonna have to fix that. All right, let's make one up. These are actually really easy, and we'll skip the practice because maybe we'll do one of those harder ones. But let's do this. I'm gonna make one up. Same base. Log of 3 equals log. Alright. Can I cancel the logs right off the bat? No. Right. I can only have one log on each side. So I need to combine the ones on the side in one log. So a sum turns into a what? Multiply. So you can combine these into the log of 3 times x plus 2. Is that all right? Yes. This equals the log of x minus 2. All right. Now I'm in a situation where I have a log on each side, so it effectively cancels itself out because you can take 10 to both sides, right, and they're gone. All right. This is why it cancels out. Okay, but it really just cancels out, so you can ignore it. So I have 3 times x plus 2 equals x minus 2. Lord willing, I get a solution because I made this up in my head. All right, so 3x plus 6 is x minus 2. Did you solve that? You have to be a little careful. Yeah, we're probably going to get no solution here. All right, so 3x minus x is 2x. If I subtract 6, I get negative 8. You're going to get negative 4 for an answer, all right? Now, here's the catch, especially with the log on each side. Plug it back into what you started with, and you see the problem I'm going to have? I get the log of negative 2, right? So that should cause you to go, oh, no, that's not a solution, okay? So even though I got a solution, it's extraneous, right? So this particular problem, negative 4, is not a solution since you can't take the log of a negative number. So therefore you have no solution, okay? So just kind of put in your brain when I work with logs, log equations, to go back and check my answers and make sure I'm not taking logs of negative numbers, okay? You've got to check the logs. The exponents are great, don't worry about. Logs you've got to check. All right, and I think that's enough because I really did push this today, okay? Well, when I get back, I will go through some of these equations. So you have 2 days to work on the stuff, and we'll see where we're at when I get back, okay? Yeah, it's still recording, I'll turn it off. And to anybody that's listening, have a good Thanksgiving, all right.